This is lecture 31. We will talk about a new topic. This is class 8. For this class, we talk about multicasting. We program some new APIs, the root client, child client, and we also program some upper level applications based on this new APIs and the distributed primitives. For this lecture, we'll talk about streaming. You can see there are not topic for this class. It's implementing Kafka with GridFree. Streaming is, I think it's a data flow. Data can flow in real time. That system is very important for the current system based on the over internet, because at this time there are a lot of data. High volume data need to be processed. There are a lot of data sources. Some data may be crawled from the web pages, from millions of websites around the globe. Some data may be created by a large number of users. Users need to post some pictures and need to post their videos and also need to comment something. There are a lot of data need to be injected into the system and to be processed. So in within such a system, I think streaming is very important. With streaming, the data can be distributed in low latency in real time, and the data can be accessed instantly. So a streaming framework is important at this time. Kafka is famous for that. Different from traditional data management approach. Kafka provide developers with streaming, so all the data be collected from multiple or various data sources and flowed from the data flow should be processed and accessed by various users, a lot of users around the globe or within an enterprise. So Kafka is very important. It's very popular at this time. A lot of enterprise start to use Kafka to manage their data. So for that, I want to, if Kafka is so important, distributed framework, whether we can implement such a application or such a framework using GridFree. No problem. That's why I want to talk this topic. I want to discuss and present how to program such a system. In this class, there's no new PIs are proposed. This class can be a new. In this class, we'll talk. You can see this class as a upper level application. This application is the streaming. So I hope we can implement the streaming framework. Looks like Kafka using GridFree. I hope this system can, when you program with GridFree, I hope you can believe the efficiency to program GridFree, program streaming with GridFree is high. That's another the reason I want to do that, because I want to show you another evidence that GridFree is a generic distributed programming paradigm. So using GridFree, you can program various distributed applications. At this time, we have talked about a couple of distributed applications, but for streaming, it's more difficult, right? It's more complicated than what we have talked about, because the scale of our system is large, the data sources is a lot of data sources, a lot of users may join this system. A large-scale distributed system need to be constructed to manage such a stream. So that's why. So for this time, we need to, I hope I can show another evidence that GRID-free is generic and self-contained and also a efficient distributed system development approach. Okay, I already create 2 applications for GRID-free. It took me 5 days to do that. I think it's rapid enough. Kafka was implemented by software engineers in LinkedIn, but according to their description, I think this system must be implemented for at least a couple of years. I'm not sure exact time, but I think 5 days. It's impossible for them to implement such a system in such a short time. Anyway, I think my system is from a product point of view, maybe it's not good enough, but I think the underlying or the distributed infrastructure is good enough. Although I think I still need to optimize the underlying techniques, but I think compared with at least the overall techniques, the APIs, the primary ideas, the major technologies are GRID-free, can be proved during the procedure, the methodology, right? Although to be a product, to be a commercialized development tool, I still need to spend much effort. Okay, 5 days. I think 5 days is fast. To program such a system within 5 days is fast enough. I provide 2 solutions during this procedure. When I implemented the streaming framework, one is called the polling broadcasting approach. The lines of code for this approach is 3,881 lines of code. Compared with Kafka, I'm not sure the source code of Kafka, how many lines of Kafka. I'm not sure exactly sure about the lines of code of Kafka, but I think at least 100. No, I'm sorry, at least 10,000. 100,000 lines of code. 100 lines of code. I think Kafka should be 1,000 lines of code. However, using my APIs and the distributed primitives and the and the new APIs of the root client, the child client, because here we need to perform multicasting, right? You can see streaming on the multicasting framework. So after we already have implemented the multicasting framework, we can develop this streaming. So using my APIs, the lines of code are much less than the lines of code Kafka. This is one solution. I will explain what polling and broadcasting means in the following slides. Another solution is a forwarding and unicasting one. This is another streaming framework I implement. In this solution, I reuse much code of the polling broadcasting one, and in addition, I program in another some lines of code. It's 1,998, almost 2,000 lines of code. The total lines of code for these two solutions is about 6,000 lines of code. I don't think it's a large project in terms of lines of code, but however, because they're using these two applications or two streaming solutions are based on my distributed my development environment, so it saves you a lot of effort. If you program such 6,000 lines of code with JSE, you almost can do nothing as if your system is a distributed one. Any distributed system you implement with JSE, Java Standard Edition, must exceed, according to my experience, must exceed 500,000 lines of code. So my system is very complex, right? Compared with the simplified distributed system such as two-node client server, TNCS. We had talked about TNCS before. Compared with TNCS, the current one, the streaming ones, are more complicated. But the length of code your program is unlimited. If you program a streaming with JSE, Java Standard Edition, the length of code must exceed. It must exceed 10. I think must exceed 100. No, 100. 100 lines of code. So it's difficult, right? It's very difficult if you program with a traditional approach. So the reason I list the lines of code for this solution, for my solution of streaming, intend to prove that grid-free is an efficient programming paradigm. This is the overall architecture of my solution. You can see here the root, child, right? There is a hierarchical structure. Here, this hierarchical structure is a multicasting framework we programmed in the previous classes. So the kernel or the core of the streaming system is based on a multicasting framework. Multicasting, as we have talked before, any scalable distributed system must be based on the multicasting framework. Multicasting is very important. It is a kernel for any scalable distributed system, any large-scale distributed system. So you can see here, this is a this is a the kernel, the root, child, and all those children nodes form a multicasting framework. And we here maybe you can start from here. Registry server, you must be familiar with this distributed node, right? Registry server, because in such a framework, in the multicasting framework, all the nodes are based on peer. Peer is a scalable distributed node. All the distributed nodes as a peer should register on the registry server. So registry server should be set up here. So it's easy to understand this portion of the framework, of the streaming framework, right? This is multicasting, this is Redis server. In addition, we add some new distributed node for the streaming framework. The first one, the most important one, is for the additional distributed nodes is publish subscribe server. Publish subscribe server. This server is also important. All the stream information should be registered on such a server. The streaming server, the publish subscribe server means there is some publisher. The publisher need to post new data. All the data sources can be called publisher. All the publisher should register their data sources on this publish subscribe server. And in addition, there are some publisher here. You can see publisher, right? A lot of some publishers are listed here. Publisher have data sources. Publishers for example, in my another application, another research project called New 3W. In such a system, there are a lot of crawlers. Crawlers access millions of websites around the globe, and all the web pages are crawled and injected, input into the New 3W distributed system. So all the crawlers can be called publisher. Publisher is in our simple streaming framework. The publisher is implemented with csclient. You must know csclient. The csclient is a typical client. It can send information, send the data to any server or any peer. So this is a data source. The data source called publisher in the streaming framework. You can see all the publisher need to register its data source. Some description about the data sources are published on the publish subscribe server. After that, publisher can send the information, can send all the data to the multicasting framework through the root. If the data is received by the root, the root can, using multicasting approach, to transmit all the data to its children. So in this case, publisher is a client in the data sources. That is the data where the data is originate, right? So data is published by the publisher using csclient, and the root, after root receive the data, it will multicast the data to its children. So it's easy to understand, right? Another type of distributed node in the streaming framework is subscriber. Subscriber is also very important. Subscriber can be regarded as a consumer, data consumer. Publisher is the data producer. All the publisher also need to register. You can see here, this line, this line, this line. All the subscribers need to also access, register on the publish subscribe server. They need to register on such a server and notify the server which data, which type of data, which topic data they are interested in. If they register such information on the pub and the sub server, after that, the subscriber will receive data from one of the children within this multicasting framework. Since there are a lot of children here, right? So all the children transmit. The children form a hierarchical structure. Data flow from the root to all the children. So there is streaming is formed, is constructed within the data flowed from the root to all the children. So one subscriber register and express interest on the publish subscribe server. Immediately after that, the subscriber should receive the stream. The data will continue, will flow from one of the children to the subscriber. Maybe there are a lot of subscribers here, so all the if the multiple subscribers are interested in one specific topic, if the number of subscribers is large, then a broadcasting framework is formed here. You can see here is the broadcasting, right? So if many subscribers are interested in one specific topic, and if this child have the data which all the subscribers are interested in, then this child become the root, and all the subscribers become the children. So a new multicasting can be formed between this child, start from the child to all the subscribers. So here you can see broadcast is performed between one of the child in the multicasting framework and some of the subscribers. So this stream data can be flowed from one of the children to all the subscribers. This is the subscriber. You can see subscriber is implemented with peer. That's why it's feasible to form a multicasting or broadcasting framework between one of the children and all the subscribers. So subscribers should be implemented with peer. Subscriber should receive all on peer. So this node called subscriber on peer. The last node is the end user. Those users interact with the subscriber usually through the request response. The user need to access this subscriber to interact with the subscriber, send a request, and maybe it search some information, and they query something, and then it got a response. So this is end user. So things they interact with the subscriber through the request response. So user can be implemented with CS client. Okay, we return to here. How to implement the publish subscriber server. How do we implement publish subscribe server? Now, in my case, it is implement on peer. So we use peer to implement publish subscribe server. Why do we want to do that in this way? First, it is easy for us to manage a distributed node with peer, since peer can register to the REST server. So if we know the REST server, the IP address of one IP of the REST server, then all the distributed nodes do not need to manage any other IP address. If the scale of system is large, it's good, right? So if we use peer, one advantage is it's easy to manage a distributed system since we can know the IP address of any distributed node according to its name. That's one advantage. It's easy to understand. Another advantage for using publish subscribe server is you implement such a server with peer is that the peer is able to forward. So if any information, any sub-publication and subscription are updated on the peer, on the publish subscribe server, this information can be forwarded to the root. This is one advantage. If the information can be forwarded, then this register information can be broadcast or multicasted to all the distributed nodes. It can be multicast to all the unicast or anycast or broadcast to all the distributed nodes. Then it's not necessary for all the children to interact with the publish subscriber server frequently. This is another advantage. So for in my solution, I implemented two streaming solution. In one solution, the publish subscribe server do not forward. The publish server does not forward. Instead, all the children, for example, those children need to interact with the publish subscribe server when the data need to be multicast to subscriber, because all the subscriber when the children need to multicast the data to subscribers, they need to know if the subscriber are interested in the data. For that, I need to interact with when one child receive data, I need to know whether which subscriber are interested in this data. For that, when new data is available, the child must access the publish subscribe server. If the volume of data is huge, the frequency to access the publish subscribe server must be high. It must increase the workload of this server. This is one solution. Another solution is that the publish server can forward the updates to the row, and then the publication subscription information can be distributed to all the children. Then it must save a lot of effort of the server, since these children are not required to access this server when new data need to multicast to the subscribers. So this is a different solutions. Another difference is that within this multicasting framework, whether we need to use broadcast or unicast, which one is better? I think both the solutions are acceptable. If we broadcast data to all the childrens, when data is published by publisher, if we using broadcast to distribute all the data, to distribute data to each of the children, then the data have many replicas. The advantage for this approach is that it's easy for us to select one proper child to perform broadcasting for those subscribers. Because a lot of all the children have the same data, so the data is replicated to all the children. So any children can perform broadcasting for the subscriber. So this is one solution. So we can select one proper one, especially when the scale of system is large. It's necessary for us to select one proper child to perform such a broadcasting. We need to select, usually we select the child that is as close as possible to the subscriber. Then the performance of the system is high. However, the disadvantage is that we consume a lot of computing resources because all the data is replicated to a large degree, right? So that approach consume a lot of computing resources, the bandwidth, the computing cycle, and the storage we need to consume a lot of computing resources. Another approach that we can perform unicasting within the multicasting framework. That means the data from the publisher is replicated only one copy. Then if many subscribers need the data, this child can be selected. This child is only one child can be selected to deal with the workload from the subscriber. This effort saves a lot of computing resources. However, the fault tolerance, this system is not so fault tolerant. Another problem is that because we have no choice, only one child can deal with the potential workload. So this system is not flexible enough. Based on that, I provide two solutions, right? Based on the description, I provide two solutions. The first solution is just called polling broadcasting solution. Polling is performed between the child and the children in the multicasting framework and the publish subscribe server. And what is broadcasting mean? What does this mean? Broadcasting means stream is broadcast in the multicasting framework. So when the root of the multicasting framework receive data from one of the publisher, the data will be replicated to all the children through multicasting. So this is the one approach. Okay. Another approach called forwarding unicasting. We talk about this solution just now. Forwarding is performed for multicasting. This forwarding is the multicast. The publication subscription information is forwarded by the publish pub subserver to the multicasting framework. So no polling is required because data is forwarding already forwarded to the broadcasting framework. And another feature for this solution is that streaming is unicast. Data, one root of the multicasting framework, receive data. Data is unicasting. So this is another solution. Two solutions. You can say I implement all of them. I will show you how to run such a system maybe in the next class, because in this time we have no sufficient time to talk about that. This time we have no sufficient time. So next time I will talk about how to run this system and explain the code. You can see it's easy. It's easy to program the solutions. You can, according to this diagram, you can say such a system is must be the most complete one since we have started to discuss gradeful programming. Multicasting framework. Okay, we talked about this one before. This is a foundation to support streaming. So that's why we need to talk about the multicasting framework before this class. Okay. Two choice. Yeah, we talk about broadcasting, unicasting, two choice. Which one is better? If transmit stream in broadcasting, each node in the multicasting framework receive data. The data is replicated many times in such a framework. The advantage, such system is advantage, right? The advantage of the solution is that the possibility of data loss should be off, right? The possibility of data loss is small because there are a lot of replicas for the data. It is flexible to select one proper child to interact with subscribers. We talked about that before. Especially when the scale of system is large, it's necessary. Maybe in some large-scale distributed system, this system it's possible for such system is distributed around the globe. The subscriber may come from also distributed around the globe. We need to select one of the child that is close to the subscribers. If the distance between them is long, performance should be low. So such a system is flexible and fault tolerant, more fault tolerant. And the disadvantage, high computing resources, high cost. Unicasting, if transmit stream in unicasting, each child receive one portion of data in the stream. Yes, right. Then each child deal with a workload from particular subscribers, which are interesting in the data the child holds. What does it mean? That means each child in the multicasting framework holds different data. So this child is the only choice because only one copy of the data is managed, is held, is received, is saved, persistent in such a distributed node. So if the subscriber are interested in the data, then there's no choice. We have to use this child to distribute data, right? So because all the data is distributed, through unicasting, so the data is distributed within the multicasting framework evenly. For that, then the load balancing can be reached, because each node have the same data, and each node is possible. In average, is the possibility for each child to deal, because each child have the one particular portion of data, so each data is just deal with one portion of subscriber. Each child responsible perform multicasting for one portion of subscriber. In theory, this is the load balancing approach. The problem is that the performance, right? We just talked about if the system is spread in a wide area, the distance is long between the subscriber and the child. There's no way available to turn the performance. Okay. Next, what is a publisher subscriber? Publish and subscribe server. We talked about that before, right? So the author, the data producer, the data consumer, both of two type of distributed node need to register on such a server. They need the producer tell the server which type of data they can provide, and the reader register on such a server and notify the server which type of data they are interested in. Okay. A peer, right? I use a peer to implement such a server. Peer is a server, so we can using polling approach to access a server, access such registry information. We can also, because it's a peer, we can also forward. I think forward, both of them have an advantage and disadvantages. Advantage for polling, the advantage is that children do not need to spend additional efforts or resources to keep the information of the subscribers. Since the children need to perform multicasting these children need to play the role of the root for the multicasting between the local child and the subscriber. So there is an additional multicasting framework should be constructed between children and subscriber. So it's necessary for the children know which subscriber should be used to form such multicasting framework. So the children need to access the publish subscribe server. So how to access such a subscribe server? We can use the polling to do that. If you use the polling, although the workload of the polling publish subscriber is high, however, it saves a lot of efforts. It saves efforts of the children. Children do not need to spend additional computing resources to keep the information, to keep the registry information, keep the interests of the subscribers. And what is the disadvantage? Disadvantage is the workload of the pub sub-server is high. Sometimes, if the system is not designed properly, the register server for the inter system need to spend additional effort. For example, if the children need to know the IP address, for this case, the register server in our class until now, the register server only, the typical address server only keeps the IP address of all the pairs. So if the children need to form a multicasting framework between itself and the subscribers, it need to know the IP address of subscribers. So if polling is used, the register server, the workload, the access server is high because the IP address is saved on the register server. So this is when a lot of children in the multicasting first need to access the pollings, need to access the pub sub server and the register server through polling. Both of the registry system must get high workload. Forwarding is another solution. It's a reverse approach to the polling one. It lowers the workload of the published server, published sub-server, and the register server. No problem, right? The interest of the subscriber is distributed to the multicasting framework and even the IP address. So it saves a lot of efforts. The children are not required to access the server because any new updates is distributed to the multicasting framework. So it's not necessary for them to access the pub sub server and the register server. However, the children need to keep all the information. So there's an additional effort. Publisher is easy. Publisher need to register topic on the pub sub server. The publisher need to implement with a CLAN. It's a typical CLAN. It's easy to implement publisher. Okay. Subscriber is should be implemented with peer because to raise the performance of data transmission between the children and the subscriber, a multicasting framework should be created. For that, subscriber need to be a peer. Otherwise, the efficiency to transmitter is low. The efficiency of the stream is low. Subscriber, also need to register their information on the pub sub server. Okay. We talked about this issue before. We talk about this issue, so we do not need to repeat. After subscribing one child in the multicasting framework is selected, is for broadcasting, right? Any child, if the data is replicated through broadcasting, any child can responsible for the multicasting between the children and the subscriber. If unicasting is performed in the multicasting framework, then only one child can perform the multicasting between itself and the subscriber. We talk about this issue. User most easy to be implemented. We have programmed with CS CLAN many times, so it's easy. Okay, this time, okay, maybe we have no enough time to talk about this code. You can see I implement this code in 5 days. This is the code I created during the 5 days. The total lines of code is about 6,000. It's not a large project. However, with the support of Grid Free programming paradigm, a streaming framework is created. It's efficient. You can also see when I explain the code in next classes, the implementation procedure is straightforward. It's easy if you use Grid Free to do that. Okay, you can see this is the code. This is the code. This one you can see the package name. This is broadcasting, right? This is child. This is client. This is broadcasting. Broadcast means this data is the stream is formed through broadcasting within the multicasting framework. And in this solution, there is a polling between children and the registry mechanism. This is another solution, unicast. You can see the package name, right? Unicasting. Unicasting, that means data, the streaming is formed, it's transmit. The stream is transmit within the multicast framework using multicasting. This is the code. This is the pub sub server. This is another pub sub server. For this server, no forwarding. However, for this server, this public server is able to forward. Okay, this is the root. This is the subscriber. Subscriber should be appear. You can see here. We are explaining the code in next classes. Okay, this is the publisher. Publisher is easy. It's just a client, right? Okay. Okay, time is up. I will explain the code, all this code in next classes. After that, I will show how to run these 2 projects, 2 solutions, and I will create another application based on this streaming framework. Okay, that's all for today. If you have any questions, just let me know. Okay, thank you so much. See you next time.